Hey students, today's lesson is on dividing integers. So we're going to do a few examples here where we're dividing integers with the same sign. Just like for multiplication, we know that when we divide a positive divided by positive, like 20 divided by 4, the quotient that results is positive. And same when we do a negative divided by negative, the quotient is also positive. So when dividing two integers with the same sign, the quotient is always positive. Go ahead and pause and write that down. Now let's do some examples where we're dividing integers with different signs. Here we have 75 divided by negative 25. Just like multiplication, when we have two different signs, the result is going to be a negative integer. So here we have 75 divided by negative 25. That's negative 3. And here we have 54 divided by negative 6. That's going to be negative 9. So our rule is, when dividing two integers with different signs, the quotient is always negative. Pause your screen and get that written down. Now let's try evaluating an expression. So here we have the expression 10 minus x squared divided by y. And we're going to say that whenever we see an x, that's equal to 8. And whenever we see a y, that's equal to negative 8. So we're going to rewrite the expression, but using the given values of x and y. So 10 minus 8 squared divided by negative 8. All right, now order of operations, PEMDAS, says parentheses first. There's nothing to evaluate within these parentheses. These are just parentheses to keep the negative sign with that 8, so we know it's a negative integer. So next is exponents. So we're going to do 8 squared is 64. So we've done our parentheses and exponents. Now we have our multiplication and division. So we're going to do our division next. 10 minus 64 divided by negative 8 would be negative 8. Now we're left with a subtraction problem. I'm going to convert that to an addition problem and add the opposite. 10 plus the opposite of negative 8 is 8, and that's 18. All right, here's example 4, a real-life application. So you measure the height of the tide using support beams of a pier. Your measurements are shown in the picture. What is the mean hourly change in the height? So here this picture is showing us that at 2 p.m., it's at 59 inches, and then the tide lowers by 8 p.m., it's at only 8 inches. So over the course of 6 hours, from 2 p.m. to 8 p.m., the tide decreased by 51 inches. So if we want to know how much it decreased each hour, we need to divide. So we're going to say the final height minus the initial height. That's how we got the 51. So we're talking about 59 minus 8 is 51 divided by our 6 hours. I'm running out of room here. Let me see if I can make some more space. Here we go. So now I'm left with 51 over 6. Let's see, 6 goes into 51, I guess, 8 times. That's 48, and then there's 3 left over, so 3/6, which is 1/2. So I get 8.5. And what does that mean in the context of this problem? What is the mean hourly change in height? So we're talking about inches. It goes down 8.5 inches every hour. All right, that's it. Go ahead and try a few on your own, and I will see you soon.